Bug brains and math magic, nature's tiny geniuses.
Hello, it's Mr. L back in the garden where things are buzzing with brilliance. Today, we're diving into the tiny world of insects, where math is everywhere. That's right. These little creatures are walking, flying, crawling calculators. Let's break it down, bug by bug.
Bees that boogie with geometry.
First up, the honeybee, nature's flying GPS. When a bee finds a juicy patch of flowers, she heads back to the hive and performs a legendary move called the waggle dance. She uses the angle of her body compared to the sun to show direction, and the length and number of waggles to show the distance, but it doesn't stop there. Bees have shown they can understand concepts like zero, basic counting, and even simple addition. Scientists trained bees to match symbols with quantities. Yep, math quizzes for bugs. They're not just sweet, they're sweet on geometry.
Spider, silk, and symmetry.
Now slide over to the spider, a silk engineer who spins with symmetry. Each web starts at a central point, then stretches out like a wheel using radial symmetry. She spaces her threads using angle measurement and distance estimation. Some spiders even adjust their designs based on how successful their last web was. Talk about real-time data analysis. And get this, orb weaver spiders often construct their webs in precise spirals, a structure so strong, engineers studied it to improve bridge cables and netting.
Ants on a mission. The algorithm army.
Next, let's march with the ants, tiny team players with serious brain power. You might see them forming long lines to snacks, but what you're really watching is applied math in motion. They lay down pheromones, chemicals that mark paths. The more ants that follow a trail, the stronger the scent. Over time, this creates the shortest, fastest route between home and food. This is a real-world example of optimization algorithms, just like how GPS apps figure out traffic routes. And it's not luck. They adapt using collective decision-making and feedback loops. Even cooler, some species count their steps to track distance. Yep, they've got built-in pedometers.
Butterfly wings and fractal things.
Now let's flutter into the world of the butterfly, a living artwork of math and nature. Those stunning wings, they follow bilateral symmetry, where the left mirrors the right. Their patterns often display fractals, repeating shapes that appear at different scales. From afar or up close, you'll see self-similar geometry that scientists also use to model trees, coastlines, and clouds. But it's not just beauty, it's survival. Some wing patterns act as camouflage, others as warning signs with shapes that mimic eyes or predators. The precision of their wing shapes and the ratio of color sections even affect how well they absorb heat from the sun. So yeah, these bugs are rocking math-powered fashion.
The mantis equation. Precision strikes with trig.
And finally, meet the praying mantis, a stealthy striker with serious skills in trigonometry. Before it leaps, the mantis analyzes the angle, distance, and timing of its attack. Its compound eyes give it 3D vision, letting it estimate how far away a target is. Then bam, it strikes with machine-like accuracy. Some species can even rotate their heads 180 degrees to track movement. Think of it like a mini drone doing real-time calculations on a moving target.
The Math Squad, nature's STEM superstars.
So let's review the Math Squad. Bees, masters of direction, angles, and even counting. Spiders, web architects with symmetry and geometry in every strand. Ants, optimization experts using algorithms and step counting. Butterflies, beautiful in design, built on ratios and fractals. Mantis, strike with trig, fast, focused, flawless. From flight patterns to food hunts, survival to style, these insects use math every mile.
Math is everywhere, even in the wings.
So next time you swat, squash, or scream, hold up. That bug might be solving equations better than your team. Stay curious, stay smart, and hit that like, subscribe, and buzz with Mr. L on your next math adventure.